build several different silos of big data platform that everybody is using today to do some of their data processing as to whatever that occurs to them. So my question I still come back to my question. Why big data? Why big data? What exactly big data offer is because of the evolution of the technologies. There is simply nothing more. Because we have technologies that evolved from the open space, so many contributions, then everybody from there, they were using their own traditional knowledge to actually extract value from what already exists, and everybody is running with it. So for instance, if you look at this ecosystem, I can take the data processing tool as it is. Can you see that the data processing tools where we have Spark, we have Scoop, we have Apache Flink, then we have Kafka. There's absolutely nothing you want to do with data that you cannot use most of this connection of tools to actually process. So if I take that, I can decide that, look here, I don't want to go with the headache of getting to set up Hadoop infrastructure. So from there, I can just take the data processing engine and use it with my RDBMS, and I'm off. Because by the time we move ahead, I'm going to give one or two use cases around some of the work I've done that they just take the data processing, then they take the RDBMS, and they move ahead. So they didn't bother much about what happens with Hive. They didn't bother much about what happened with NoSQL. But in some other instances, there is absolutely nothing they can do without actually using the entire ecosystem. Maybe probably they take the storage layer, take the Hadoop storage layer, then you use one of the resource management to configure where some of your data analytics query is going to come out. Then you begin to use Spark and Kafka all together to process your data. Then you can decide that, fine, I want to go with a particular NoSQL database. Then you still choose RDBMS. For instance, when you want to have a complete, Lambda architecture for a data lake, a complete Lambda architecture for a data lake, you are going to choose most of this landscape. You're going to get involved in Hadoop. You're going to get involved in RDBMS. You're going to get involved with NoSQL. You're going to get involved with so many other things. You get my point? So this ecosystem is actually rich enough to help us to facilitate data processing capacity within our organization. So like I said, it is enough for us to facilitate data processing capacity within our organization. So let's still go back. Why do I now need to choose the ecosystem? Why do I need to choose the ecosystem? Now, let's look at this advantage. Let's look at the advantage that most of these ecosystems have to offer us. Now, varieties of tech innovations, like I said the other time, what works for me? I can take whatever that works for me and I move ahead with it. And I'm fine, I'm good. Then I'll begin to do my business and I'll begin to do a lot of analytics and processes and insights for my customer. But suddenly, you just discover that the customer just overgrown their data processing capacity. And you now begin to say, oh, you have to tune, you have to do this, you have to do tuning, you have to rewrite your query. That's one of the big advantages that big data has actually offered. Most of the performance metrics that you need to do does not actually involve you retweaking or rewriting your codes. What happens most of the time are just mere parameter settings and some other things. So from there, you just move ahead and you do whatever you want to do and go. One other advantage that it has is the cheaper cost of acquisition. Is there anybody that has any question? Any question, please? Any question?
If you have questions, you can ask or you can type it in the comment section below.
Are we all following now? Please let me signify if you are following, please, so that I'll be sure. Okay, all right, thank you.
Yeah.
All right, thank you. Okay, so like I said, varieties of technology innovations is one of the things that bring advantage. Then the cheaper cost of acquisition. What do I mean by cheaper cost of acquisition? Let me tell you, one of the major breakthrough of big data acquisition is basically, fine, what makes it cheaper? My data processing engine is pure set of libraries that are fill some of my what do you call it, data processing capacity. Fine, do you get that? Then it's platform independent. It's platform independent. Now there was something, there was a revolution that happens that actually makes that to be great. That was the X86 Intel processor. X86 Intel processor. X86 Intel processor. Hello, are we there?
Go ahead, sir. We can hear you.
All right, that's fine. So x86 Intel processor was one of the very big breakthrough, because on x86 Intel processor, you can run most of these open source solutions.
Yes.
So before somebody will tell you, oh, you can't do this on Linux, you cannot do this on Windows, you can only do this on Mac, you can only do this. But because of the evolution of x86, we're able to probably assemble most of these open source solutions. So when you assemble most of these open source solutions, then probably you can move ahead. So for instance, now what I need to do basically when I have data sitting down in different locations is I need to get data from this source. I need to get data from this source. This source is Microsoft. This source is MySQL. This source is Oracle. This source is from web. This one is from Twitter. I don't need to buy any adapter. I don't need to buy any database adapter solution for me to connect to most of the data sources. So adapter license is off. That is second one. So the first one was that all the data processing engines, they are just set of libraries. I don't need to buy that. Then adapters to connect to most of these data sources everywhere, to anything Microsoft, NoSQL, you don't need it. You only need some level of JDBC drivers. Then you are done. Then what else is that? Because communities are actually interested. Communities are actually interested in all these. Communities want to see how they can drive their business without incurring so much cost, and they can at the same time derive the same value from whatever they are doing. So community interest was there, and at the same time, it's very fast, because when you're using a big data platform for your data processing capability, there's one thing that is certain: you are going to be using complete in-memory capability to process your data. What do I mean by that? Every data that I'm using at that particular point is actually located within the memory, within the memory of that particular system. And when data is located within memory, it makes it faster, because the distance between the memory and the CPU is almost about 10 gigabytes. And the distance between memory and disk is very high, very, very high. So that's why big data processing does not do what they call I/O processing. It does in-memory capacity processing. So when I take data from anywhere, I put it in my memory. When I get to another place, I retrieve the data from my memory. Then I can use it, and I move ahead. Then, if you want to scale, you scale horizontal. What I mean by scaling horizontal is, fine, I have a very small box. a very small hardware box, which is like 64 gig of RAM and 200 gig of hard disk. Tomorrow, if I want to add another node to that cluster, I can go and bring very small box of 256 GB memory and 1 terabyte. They will sync. They will synchronize. So that is scalability. But if you are using an engineered system, you have to get across to a particular OEM before you can do some certain things, and you are going to actually incur a lot of costs to get an OEM expert or an ACS expert to come and work on that platform for you. So big data platform brings a lot of opportunities. It brings a lot of flexibility. It brings a lot of joy to a lot of enterprise processes. And it was highly embraced. That's why community interest was much. A lot of open source projects were there, and people were moving around to get it, and we're just learning. But one or two of the biggest disadvantages that it offers, there are many multiple points of integration and handshake. So you install your data processing engine here, you install your storage engine here, you install your what do you call it? Your streaming solution here. How do you now converge? How do you converge your logs? How do you put your logs together? So managing the platform is actually one of the most tricky things, and that is why you guys are there. So you need to understand the core concept so that you'll be able to channel your energy into actually the right thing to be able to know, so that at the end of the day, you know that, okay, fine, what I'm confronting is a monster. As simple as it is and as available as it is, you are going to be spending a lot of energy to actually get that platform running as expected. And one other thing is that there are a lot of inadequate technical support services. Okay, let me give you an example. Cassandra is one of the big example of one of the technical tools that doesn't have a lot of support. So some people that have started using Cassandra before now, some of them are not getting enough support from most of the online forums that I belong to. You will see somebody posting questions on Cassandra, and they are not getting a response. If you post any question on NoSQL today, on MongoDB today, now in the next 5 minutes, somebody is going to pick it up. So those are the things you need to consider. You have to consider most of those environmental conditions, environmental influence, when you are choosing a big data platform environment for you to adopt it as part of your big data, as part of your data processing engine. You have to take that into consideration. Now, how do you now transit? How do you move? How do you move from normal traditional environment into your big data environment? So I'm going to use 1 or 2, 3 use cases of what some of these organizations have actually started with. You know, when you are moving from one technology to another, you have to be very careful. You be very careful in the sense that business continuity is very important. And once you adopt a tool and it fails at initiation, you have lost business confidence. So you need to be careful. And you need to be careful in the sense that you need to choose a particular part, a particular segment of your business that you are going to actually use to do that test run. So you need to be very careful. So in telecoms, what they normally do is that they use their core data record ingestion process as one of the first layer of test for a big data solution. Because at that point, what they are actually doing at that point, basically, they are actually warehousing on core data record. They call it CDR in telco. They are just warehousing core data record. For instance, what they call core data record is that when you pick your phone, okay, let me see. Did anybody knows what core data record is? Have you heard about it before?
Yes, I do.
Okay, you've heard about core data record.
I've actually worked with data record actually.
Okay, all right, that's fine. So the issue there is that they push most of those records, right? When you're making a call, and you are dropping the call, there's a particular record that is actually written for all the conversation that you have made. For all the transactions that you have made for that particular call, and it's going to be written from the switch directly into a file, and the file will be pushed to a particular location. And mediation, there's a system they call mediation. That is, it mediates between the switch and the storage. Mediation picks it and pushes it into that storage. So those are the things. That is what telcos does. That is what telcos start with. But today, there's so many telecoms operators that I know that most of their analytics platform have completely been moved into a big data environment, and they are not actually regretting doing that at all. And it's been a lot of influence and what do you call it, time to delivery. Let me give you an example of what I call time to delivery. So if a telecoms, okay, I've done about 4 different telecoms data warehouse projects, and 2 of them we use big data tools to deliver 2 of them. And let me tell you how big it is. A particular telco has data size of almost 500 GB for only their voice call daily. 500 GB of data daily for only their voice, just for voice call alone. And they have about 13 different file streams, from voice, from SMS, from MMS, from GPRS, from RBT to service subscription, to service request. Just name them. Now, if you now want to query for a particular customer, you want to see some of his call history. You want to see some of his call history. Call history ranges from he has done recharges, he has done SMS, the guy has buy data, he has done MMS call, all sort of things like that. Now, if you want to do a call data record, now I said earlier, don't forget, if voice data alone is about 500 GB. GPRS data, that is data itself cannot be less than 1.5 terabytes. How do you query such data to get a record for a particular customer? Maybe a particular customer that made about 45,000 calls within a space of 1 hour. How do you do that? This is one of the things that call for big data processing. That's one of the things that call for big data processing. So at that particular point in time, somebody want to, okay, for instance, as a customer, as a particular subscriber on a particular telco platform, you just recharge your phone and you made calls. Your data is not separated from other customer data. Your data is going to be written as a record from the switch into a particular location. Now, suddenly, you discover that all your credits has been wiped off. You need to get your history. You need to check your history to see what you have done that wipe up your data. And that is where it comes to a point where you need a big data platform to do that. Because reason is this: if you want to do that on an RDBMS environment, you are going to be running what they call an I/O. What they call an I/O, input-output operation. So you are talking to a disk, and don't forget that the distance between disk and the memory and processor is very far. And the connectivity between them, I'm not even sure it's not even up to 4 megabytes. Compare a processing of data that is moving between 10 GB capacity. So if you are moving from memory to CPU, you see the advantage now. So every of the big data, what do you call it, data processing engine, they are actually in-memory processing capabilities. So they can easily communicate between the CPU and the memory at the same time. And it makes the data processing faster and very, very reasonable. Let's go back to banking. Most of the banking institutions, they are actually operationalizing their data backup. That is how they start. At least I've done one in one of the Nigerian banks. So most of it, they pull data from their banking solution, they keep it on the hard disk. For most of the regulators to actually come when they want to do regulatory operations. For instance, if you are expecting like an auditor from CBN to come and access your data, you just separate your data into an environment where they can easily process data faster, and they move ahead with it, and they can operate as fast as they can. So those are the things, those are the advantages. But let's now come back to banking. If I want to run a real-time analytics. For instance, on Fridays, let's say every Fridays, I'm always on Adeola Odeku. And when it is around, maybe Adeola Odeku on Victoria Island, and when it is around 6 p.m., 6:30 p.m. and 7 p.m. every Friday, I always make withdrawal around that place. You get my point? Please, are you following?
Yes, sir.
Okay. All right, that's fine. So, I always make withdrawal, or I use EcoBank ATM, and around that particular time, along that road every day, I always make withdrawal. 6, 5, 6, 5, 6, 7, 8, 6, 7, 8. I make withdrawal. I withdraw money from ATM because I have an ATM location-based system configuration. So you can see that as a data engineer or data analyst or data scientist or data architect. You can see that. Now we are coming to business now. Now, let's now assume there is an eatery around that particular location that wants to get information about customers, that potential customers that can actually buy their product within that vicinity. The bank can actually have a business along that line and explain that information to their banks and to their customers around them that come. If a particular customer use our card here and you can give a discount, we can help you to drive traffic of customers into your restaurant. But it has to be real time. It has to be real time. How is that going to work? It has to be real time because immediately that particular customer is withdrawing money, I need to send him a notification that this particular restaurant is offering as soon as 45% discount this night before that customer takes that money into another restaurant. It has to happen. You cannot do that. You cannot do that on an RDBMS. Okay, if you want to go into a core banking solution and pick data and start running analytics. Is that one more important to you than for your customer to be able to be served? So that is one of the advantages of big data solution. Big data solution, like for instance, Kafka. Kafka can give you what they call a middleware layer, where you can get every information before the information gets to the database. Kafka has picked the zone, and it will send it to my analytics engine, and my analytics engine will run a process run a particular machine learning algorithm to discover if this particular customer is a potential customer to go to that place to purchase that product. Then that would trigger, maybe trigger an SMS or trigger an alert on the particular, or send SMS or trigger an alert on a particular banking app that will send a pop-up to the customer and say, oh, there is a gig going on here tonight. If you use our card, you get 10%. So that is selling. So selling is going on. So that is one of the advantages that the big data has actually offered into so many industrial players. Another side is insurance. At least I was able to do a total re-engineering of a particular one of the most prominent insurance company in Nigeria. It was like a play, and we started. So what they do basically is that they normally use, insurance believe that their data are not big, and they normally use vanilla Python to run their data loading, and so it's been okay for them, because insurance business, the way it's run, I don't think there is anything that is more pressing and that is more pressing, and at the same time there is nothing that is like a real-time need for them. The most important thing is that they want to do some calculation to be able to know their loss adjustment. If somebody wants to make claim and some other things, then they can see the history of what that particular person has done. Now, let me not give you one very, 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 very tedious part of their use case. Okay, so I'm a customer. I subscribe for motor vehicle insurance, and I subscribe for fire insurance, and I subscribe for life insurance. And I started running an insurance subscription with them from maybe 2012 for motor, and for 2014 I joined with life. 2017 I said, okay, come and insure my house for fire for me. Now, if care is not taken, and when you want to report, when you want to give an insight into what customer is doing, you need to give every information about me in a single record. That is what they call smart reporting. So does that mean that if I'm processing today, I have to do what is called go back to 2012 for this particular customer, go back to 2017, then go back to 2015 to track all his record. So they are doing it, and they are doing what they call daily. They are doing what they call daily upload. What they do is that the entire analytics process, they run it on the entire day. So they will go from like 16 years that their business has started, and they will run, because their data is just 1.8 million. I now ask them, the day you will grow this business, to 900 million, you will look for somebody to help you out. You will pay through your nose. So it's better you start from now. So from there, we're able to adopt distributed computing. We only use Spark and Postgres database to run that particular process. And believe me and you, what they've been able to do, their model was perfect. They can see a snapshot of customer that has been with them for over 60 years on a single record. A lot of data modeling when they actually, but because we were using a big data processing capacity, that enhancement alone was superb, and everybody did not believe it when we come out of that project. And in fact, it was very seamless. And as I'm talking to you today, most of their digital solutions are running side by side that particular platform, and they are up and doing. They are up and doing. So even if they grow as much as any possible means tomorrow, what it means is that it's not going to be any fair for them anymore. So they've already started. They've already laid their feet on the path of greatness. It's not going to be anything new to them. So if their data grows tomorrow to 15 terabytes, and they want to add the storage layer. They want to add Hadoop as the storage layer. They already have the data processing engine, which can communicate fluently with Hadoop. So those are very fascinating experience that big data will bring for you. In one of my projects somewhere in telco, that was in Cameroon, they have a mobile app. Their mobile application is sitting on live CDR, and what they are using it to do was the same thing that I explained to you the other time, like call data record. They are using it to do call history. So customer can go to that platform on that mobile app and query their call history for the past 60 days on a go. And for instance, if a customer recharge now, and he wants to see if that recharge was successful, he will just go there and query their call record. Automatically it's there. The engine was developed in such a way that we were moving data from the mediation to the final table in less than 2 seconds. And that is the power of big data processing engine. I remember in those days when we normally process data, called data record, we were using shell scripts. And when you have a problem, when you have one particular problem, just one single problem, you might be there till tomorrow. In fact, most of the time, you might have to sleep in the office for you to get that problem resolved. So it's a lot of what do you call it? It's a lot of challenges getting data processed in those days compared to what we have now. But one of the biggest challenges that we just have today is the varieties of technologies. The variety of technology that are available. So that's what I said. You have to take what works for you. Take whatever that works for you and run with it. Just take whatever works for you and run with it, and you are good to go. By the time you need to make a transition into something else, it's not going to be very difficult for you. It's better for you to start than never to start at all. So that's one of the big breakthrough in data processing environment that actually bring a lot of solution to some of us that are playing data steward in that space. So what does it take to be a big data pro? Let me just cap it off with that. What does it take? One thing that takes first is confidence. Yes, it's confidence. Okay, I remember one of my projects. I was going outside the within a country in West Africa to do a project, and my MD then will ask me, "Are you sure? Are you sure when you deploy this solution, it's going to work like this?" I said, "Yes, I'm sure," because that was the first time. That was the first time I was going to deploy a big data production environment. The other ones I was doing before then was proof of concept, but this one was a big data environment. So he kept asking me that question. Even when we were building, he was asking me, "Are we sure? Do I need an assistant? Should he contact a company in Germany? Should he contact a company in India?" I said, "No, I will deliver this project using this tool." So you must be confident. And what has given most of this confidence is because I was able to articulate some of my experience, and I said, okay, fine. If I'm able to do this using the traditional method, how am I going to achieve it using this method? That is one thing you need to know first. If you are able to do this using a traditional method, how do you achieve it using this new method? That is it. How do you achieve it using this new method? And that is the question that will keep running on your head. And that will actually form the basis of your footstep and your direction. So you go that route. So when you seek proper traditional data processing experience, like I said, so I'll be doing this way, and I want to do it this way. How am I going to achieve it? Then you look for resources that can help you to follow that path, and then begin to move gradually. As you have moved past one level, you document it, you move it ahead of you, you move another level, you document it, you move another level there, you document it. So from there, you build your confidence. Then one other thing that you need is that you need a knowledge of multiple tools doing the same thing. Let me tell you one of the most things that actually helped me out. When I started doing big data ecosystem through orientation, I write what they call PLSQL. I write what they call PLSQL in Oracle environment or T-SQL in Microsoft environment or whatever. I know how flexible it was for me because what I've done over years, so I've been able to master it. And I said, how am I going to do this on this? Then I started reading Flume. I started doing Scoop. Now, if I now need to process 6 month data, I want to process a 6 month data, daily, cumulative, 6 months. I can't get that from my Scoop and Flume because why? Because I cannot spool 6 months data once. And there was no iterative process in those tools. Then I began another research. I started another research on Spark. And Spark eventually now gave me everything that I need. And I stood with Spark, and confidently I was able to deliver at least so many other projects using Spark. In fact, if I close my eyes and you said you have no problem with Spark, I can tell you totally that this is where the problem is. This is what it is. So it's so flexible. And mind you, one of the advantage and one of the very, very great things is that if you want to do something using the traditional way, maybe your code will be about 180 lines. But when you are using big data tools, you might just write 3 lines of code and your job is done. Okay, let me even take you, let me take it a little bit further on when we were using Oracle data miners to build machine learning. It's a war. Whenever you have a failure, you don't even understand what is behind that particular notation because we're using a studio. And you will discover that you have to start building that model afresh. It was a tough one. But when I started building machine learning on Spark, I just discovered that I just need to understand business. My line of code with less than 16 lines of code, I've built my machine learning. I'm done. I'm off. I've operationalized it and I move ahead. So you see what the platform has brought: a lot of confidence, a lot of assurance, scalability. You keep moving, you are growing. Then interoperability. I can write a particular library. In Python, and I will take that library, I'll call it in my Spark. For the fact that that library in Python is already parallelized, Spark will still do a parallelism. So if I've been running a process for 13 hours before, at least I know of a process that used to run for about 13 hours before, that we need, when we use the big data to process it in 30 minutes, we're doing it. 30 minutes. So it's a platform to stay, but the technical support services is what is needed, and you guys you're already on the right path now. So you need to prove to yourself that you are actually you are going to commit a lot of your time, a lot of your resources, a lot of your energy, a lot of your influence into it, and actually make it to work for you. And you have to actually be able to talk. You should talk to people about solutions. Some people will be asking me at times that, why is it that you have so much confidence? By the time I explain, oh, there is something wrong in this place, I was the technical lead, I led that team, I build the architecture, I do this. Those are the confidence that you need. Because some people will tell you that this type of project has never been successful elsewhere. Who told you it has never been successful elsewhere? I used to tell anybody, I've never done a failed data warehouse project in my life. I've never done a data warehouse project that failed. So those are the things that you have to put. Continuous learning. Just keep moving. As much as study as possible. Keep moving. Move. Now, okay, sorry, somebody is asking a question. Yes, but for Microsoft. Sorry, somebody is asking a question, I'm responding. Yes, so somebody asked a question, he's saying that is PLSQL the same thing as Transact SQL? It's the same thing, but Microsoft call his own T-SQL. Oracle call it PLSQL. Postgres call it PSQL. So what the PL means is the procedural logic, and Microsoft call it transaction. You know, when you are writing SQL, you cannot modularize it. SQL cannot be modularized. And for instance, if you now need to touch about basically about 7 different tables, you need to touch about 7 different tables to fulfill a particular analytic request. So what you need to do is to write different, you will now write like a subquery. Subquery is a killer. So that is what brings about interactivity, iterative. So PLSQL, T-SQL, they are called iterative data processing. It's called iterative data processing. So it's the same thing. Yes. So like creating a store procedure in Oracle. Exactly. Thank you. Exactly. Thank you. So that is it. So you have to continue to learn and continue to unlearn. You have to explore. You need to know variability. You need to know versioning. You need to know what works here. You need to make some findings, further research. But you still have to be moving with what works for you. Because in the last 1.5 years, I noticed that the ecosystem have slowed down a bit now. There is no new things coming. The only thing that is actually coming on this ecosystem is people are adopting all the tools within the ecosystem to actually develop a solution. Like I said in my profile, what I do mostly these days is most startups and organizations that are building big data environments, those are the people who I architect for. And there's a particular tool that is coming out by the grace of God before the end of August. At least I was the one that architect that particular platform end to end. And I built all the ingestion, all the data ingestions and the analytics within the tool. It's a big data tool. It does what they call DevOps operation. You just sit down like this, on a click, you set up the entire Hadoop clusters. If you want to provision on 1,000 Hadoop clusters on a click, you do that. Then from there, we have a lot of libraries that we've deployed that you can just do a simple configuration and your data loading starts immediately. So that is what people are now doing with the ecosystem. You take whatever that exists within the ecosystem, you play with it, then you use it to build a tool, then you brand it, you wrap it up, then you take it to the market. Because it's been very, very difficult. I can't lie for you about it. It's very, very difficult to manage most of these tools within the ecosystem because there are many. But by the time you put them together as a solution, you have a single point of monitoring, a single point of monitoring, a single point of reporting, a single point of alert, a single point of logs and some other things. Then that will actually enhance your productivity and you'll be able to move ahead and move faster so that you can move to other business as soon as possible. So thank you guys for having me there. I think that's just the brief I have from the use cases, and I want to be sure that you guys were able to have an insight into most of the use cases that is expected within the big data ecosystem. I will be entertaining questions from whoever that have concerns so that everybody can listen, then we can both share experience at the same time. Thank you very much.
Thank you so much, sir. Thank you very, very much. So if you have any questions, please, you can ask your questions. You can also raise your hand and signify, and we'll also you can unmute your button and ask your questions. I think there is something. Oh, okay. So do we have any questions? And comments, or do you want to share anything? This is to the house now. Hello, everyone. Oh, okay. Daniel is saying he was raising his hand and his icon wasn't showing. Okay, so Daniel, you can unmute yourself and ask.
Okay, thank you very much, Mr. Isaac, for your session. I was really thrilled by all what you said. Okay, sir. Earlier this year, sometime around June earlier this month, I started reading into cloud computing, and now considering the Hadoop ecosystem, I'm wondering, does the Hadoop ecosystem mean that they are creating a private infrastructure in the company? And since data is evolving, getting bigger, won't they have? Is there a way that they are turning into an hybrid solution, especially in Nigeria? I also know, like, are they already deploying cloud computing solutions in Nigeria, or is strictly just, because it seems to me like Hadoop is strictly just private infrastructure in which they are doing everything on premises.
On premise, okay, all right. Thank you, Dan. No. Let me quickly try to add one thing faster, so that others can benefit. Most people have actually met, they will be asking me, oh, they want to learn data engineering, but they would like to learn data engineering in cloud computing. And I told them there is nothing like that. The most important thing is to actually understand data engineering concept either way. But it is very, very good most of the time for you to set up your own environment or within your own premise and actually understand what data engineering is all about before you eventually have to move to the cloud. So now, Hadoop infrastructure, like you said, that you have asked, Hadoop infrastructure, either Hadoop infrastructure or hybrid, whatever, is a prerogative of organizations and to some other regulatory bodies' policies. For instance, let me give you an example. Like CBN is going to give CBN will give some policies and says some sets of data cannot go on cloud. That is in Nigeria. But in the other societies, nobody stays on premise. I'm not sure anybody still stays on premise anymore. So you can actually go on cloud, provision your own cluster, and install your Hadoop there yourself. And the only thing that is going to now happen is that your data, if your application resides within your environment, you will now be doing a data pull from your environment into your cloud environment. Or basically, if you are using one of the proprietary cloud solution providers, they always provide what they call a gateway where you can actually move your data from your environment into your cloud space. So for the fact that they are saying they are in space does not actually mean that, oh, is their solution. When they get to space, they will provision your own cluster for you separately. And what they will do is that they will install your own big data infrastructure or your own cluster, and they will give you access to that particular infrastructure. So most people don't actually understand that. They thought that when they log into what do you call it, Amazon, they thought that everybody is logging into the same server. No. Each of you are created a particular different clusters where some of your application is installed for you. So did you understand that question now?
Yes, I do. Thank you very much.
Okay, all right. So that is the idea, that is the logic behind that. But it's always very good for you to have a better understanding of what is actually running on ground before you now say, okay, let me now go and join. See, actually, for most of the business owners, they will always want to go and join what is on cloud. Then from there, they will begin to learn what is there. Then they will begin to use the thing. Everybody wants to go on cloud. Even the solution I was talking about that is going to come out soon, is going to be hosted on cloud, and everybody go there, then we can spawn your clusters for you. Then from there, you can use it and you move ahead. So that is exactly what is actually happening. Thank you.
Thank you very much, sir. Okay, I have another question. So, earlier when you were talking, you mentioned data lake. I know
Okay.
there was earlier this month, so there was a argument, or let's say a disparity between what a data lake is and a data warehouse. But maybe because I was running the analysis track, I didn't want to really. So, can you shed more light between what a data lake is and what
Okay.
warehouse?
Okay. All right. That's fine. So within your data lake, from your transaction application, your data goes into your lake because your lake can take real-time data. But you must have done some middleware configuration from your organization that will actually take that data into your lake. Then from your lake, you can now begin to build your analytics layer, and that is where your data warehouse stays. And at the same time, from your lake, you can actually be feeding an external downstream system and at the same time. So that is where we come about Lambda architecture. I think, let me see if I can see a symbol of Lambda for you to understand. I think you know what Lambda is. You know that symbol of Lambda, exactly. So if you look at the symbol of Lambda, you look at where the entire thing is, that place is where the lake is. So the lake is actually feeding the data warehouse, and at the same time is feeding on that transaction. So for instance, like I said, you put your banking mobile apps. I'm going to put your banking mobile apps. I'm not going to put it on your call banking solution. If I want to do that design, I'm going to put it to be talking to your lake, because the lake and the transaction and the banking solution transaction, they are in sync. They are both talking to each other real time. So what lake does in that place is lake that does distribution. So from your lake, you can go and pick your data warehouse. So what it means is that within your data warehouse environment, you are not going to keep any raw data anymore. So what you will have on your data warehouse level is the pure analytics layer and your semantic layer that you are going to use to be doing your reporting. Why data is moving from that lake at the same time is going to some other transaction like your mobile application as well.
Okay, sir. So can I say a lake, inside the lake, you can have the data warehouses in it?
It's not inside the lake, actually.
Okay.
It's not inside. It's not directly inside the lake, but they can coexist.
Okay.
Yeah.
Okay.
They can coexist within the same network.
Yes, sir. And my final question: data, the big data analyst and big data world now seems like it needs a lot of highly specialized professionals.
Yes.
Okay. So what do you?
So come in. Continue.
Okay. So what do you advise for we that we actually just we're vying to go into this field, and right, we are coming up, but we want to actually get in and get get employed, or get in and start working.
Okay. So what you need to do, what I would advise. Are you true?
Like they need high professionals. So I'm done. Yes, I'm done.
Okay. So what do we call light professionals? What we call light professional basically is somebody that knows what do you call it? How will I put it? Is somebody that knows very much about a particular technology area. You get my point? So basically, yes, it is required, but there's no way you have to go through the ladder. You have to follow through the ladder. So most importantly, you have to exhibit some high level of confidence. That's, like I said, high level of confidence. You should look for data solution architects that you can converse with and keep asking different questions. ask different questions. Then try to understand what actually makes up each of those divisions. Let me give you an example. In most of the fora today, when you get to somewhere like LinkedIn, you will see somebody will say, it's a data scientist, it's a data scientist, they are data scientists, this is a data scientist. At least when I in my former place of work, I do interview all the time. And when I see somebody sending me connection and say, okay, it's a data scientist, okay, come for interview. When I get to the interview, I will ask few questions. Now, one of the questions I ask is that, have you actually built some semantic models before? Don't even talk about machine learning model for now. Have you built a semantic layer model before? Now, what is called semantic layer, he doesn't know. And I will say, okay, what are the data sets you work with? The data set you have worked with is you go to somewhere, a data is prepared, and you pull the data, and you start using the data. So with that, if that is where you want to be, it's better to be a pure, what do you call it? A pure data science, a pure data scientist, in the sense that all you can do is to always be waiting for data to be prepared for you. You cannot prepare the data yourself. Data is already prepared. So it means that you'll be expecting input from a data engineer at all times before you can do anything. Now, let's now go to a data analyst. A data analyst basically is just to do descriptive reporting. How is my business doing? You take the data, you plug it to Power BI, you show plots. Oh, today we make 30 naira, tomorrow we make 20 naira, you do this one. You cannot make suggestions to the business. You can only tell the business, oh, from this data, this is why this. No. But when you are a data engineer, you have insight into the entire thing, everything that happens. You might not actually be able to go to that level where you now begin to do some high-level statistics, but you can do virtually everything that everybody does within the data professional silos. So what I'm going to give basically is just to keep your eyes opened, get talking to people that are already in the field. Let's see if there's anybody that has a project that is going on. Be ready to offer, not free but per se, but ready to offer yourself for learning, so that when you join a live project, then you can see everything. In fact, you can become somebody that will actually take over the entire thing that is running within that environment. So you have to hold your passion. Then you have to turn up your game. You keep learning, just keep learning and learning continuously without any end to that. So I'm very sure with that, you'll be able to get exactly what you want to achieve.
Thank you very much, sir. On that note, I'm sending you a LinkedIn request, a LinkedIn connection request, sir.
All right, thank you, Daniel.
Thank you, sir. Thank you. I don't know if we have any more questions, especially with what our expert has, some of the last comments our expert made mention of. I don't know if anyone wants to, I don't know if you've had like questions swirling in your minds, but that would be a good time to ask some of your questions. I don't know if I'm just going to give room for more questions if there are any. Okay. Oh well, I guess that's it. So I'm gonna assume that everyone, actually soaked in a lot of knowledge today, and they are good to go and all pumped up and excited. Let me just take out this time to just go over a few things that our expert has made mention of today. Of course, talking about big data platform, what does it take for you to be a big data pro? You have to be confident, of course. A lot of you just be confident in yourself, be confident in the ability. Don't second guess yourself, because that's a big issue with a lot of data engineers and data scientists. They second guess themselves, but be confident in your abilities and what you can offer. Seek proper traditional data processing experience, of course. That's one of the reasons why we have this platform, so that you guys can learn, you guys can understand some of the nitty-gritty that goes on. So another thing is also have knowledge of the multiple tools. Be very vast. Expand your horizon, expand your scope, expand, have that knowledge, have a knowledge of multiple tools, initiate a platform change and present performance evidence. And you have to also learn continuously, keep moving, keep studying. And that's why we also have this platform, so that you guys can study, learn, and we bring experts so that they can talk to you and explain some of the things that goes on in the real world. So on that note, I think that's basically it. I'm super excited and happy for today's session. Open your eyes and offer yourself to learning. That's one of the few statements that our expert also made mention of. So I think we can all just round up today. Thank you so much, sir. Thank you so much. In fact, I don't know how to thank you enough, because I know we didn't really give you that much time, but you came in swinging, of course. So thank you very much, Mr. Dewumi, for your time and for your session today. It was just truly inspiring. Thank you everyone for joining us today. Again, next week is another time. So I think for now, I think we should all unmute our mics. Everyone has just been so quiet and everything. So let's unmute our mics and just thank our speaker.
Thank you so much, sir.
Thank you, guys.
Thank you so much,
Thank you very
Mr.
much, sir.
Adewale.
Thank you so much, sir.
Right, thank you, any.
Thank you. Thank you, everyone. Thank you so much. Thank you so much. Thank you. And everyone, thank you. On that note, we'll end today's session. Thank you very much, everyone, and have a wonderful time.
Thank you.
Oh, yeah. Thank you, everyone. Thank you. Bye-bye, everyone.
Thank you. Bye.
Bye.
Thank
Okay.
you. Take it up. Bye.
Bye. Thank you.
Ebube, kindly leave the call.